But I want to make sure that we have plenty of time for Victor to share his ideas and then have some question and answer. So I'll turn it to him, but just if you don't know Victor, I have my little official bio here. He's an associate professor at Stanford, and you are, what are you? The lead on the Stanford Accelerator for Learning's initiative on AI in education. This makes sense why you're here. And Victor does other cool stuff. He knows a lot of fun things. You can ask a lot of good questions, but let's welcome Victor.
Hi, thank you. Really nice to see some familiar faces. I don't think David had mentioned, but for almost 11 years as a professor at Utah State University, so I'm quite familiar with the state of Utah, and in 2019 moved to Stanford, which is, as Antonio Jose, so much more expensive. And although I think you're rapidly catching up on the housing prices here. So I'm going to talk today about opportunities and challenges for designing AI literacy resources for K-12 STEM disciplines. And I understand that there is, potentially given the nature of the Rossi lecture, folks who are focused and interested in undergraduate STEM education. So, to the extent possible, because as we know from the lengthy add-on title that David read, I have my hands in a lot of AI pods, but I figured this would be the one that I'll focus on, but in the Q&A or other discussions we can expand beyond the domain of this. So, many of you may already be aware that AI is a thing right now, and it's been really interesting for me because as I was sharing earlier at lunch, I have an undergraduate degree in mathematics. I also have an undergraduate degree in cognitive science, which was always really fun to explain when I was an undergrad. And so I basically said it's basically artificial intelligence, which back in the 90s was like, oh, okay, that sounds all weird and out there, but now it is a huge, huge deal, and it's core to a lot of the things. So it gave me this really intimate understanding and appreciation of where AI was and where AI is now. But just as some historical background, the sort of modern treatment of artificial intelligence as academic focus is about 1950s and 60s. It coincides with the cognitive revolution when computers became a really interesting and compelling tool for modeling things, especially modeling intelligent seeming behavior. And so then initial investments happened into the 60s and 80s, and there's a lot of push on symbolic modeling, expert systems, trying to do knowledge representation in there. And then there were some big philosophical issues that had come up, which made it seem highly intractable to make meaningful headway. Around the same time, this parallelist or connectionist model, which is the underpinning of neural networks, was coming into vogue, but those techniques were reliant on a lot of data, and that just didn't exist. And it was very time-consuming to get processors to do that. But then in the 2000s, a few things happened. Google, mobile phones, everyone living on the internet, TikTok, and data exploded. Big data, computing, this is so much faster than this super high-end computer I had back in college, and it's just going to get faster and more expensive and thinner and require continued upgrades and new connection ports over and over again. But in 2022, late November 2022, ChatGPT came out and social media blew up, and that was like rocket fuel for AI, and since then it's pretty much anything that anyone can talk about. But I wanted to put this in a little bit of historical context because even when thinking about AI in education, we already had green shoots for AI even before this rocket fuel explosion. So a few things that I'll point out is AI for K-12 started in 2019. This is an organization that's based primarily out of Carnegie Mellon, the University of Florida. And they were advocating education about AI prior to generative AI being a thing. So just even when people were thinking about, maybe we should teach about recommender systems, or what is machine learning. K-12 data science education, curricular momentum accelerated, especially around 2020. In fact, Gail Sinatra, hi.
Sorry, I got lost. My bad. Sorry,
I didn't expect you here, but cool, welcome. Data science for education, and for everyone, blew up, and I understand Utah is also integrated into their state standards, but this is around 2020, and so that's become a major focus, and we noticed that's before 2022, and a lot of the interest around data science was also tied to the machine learning and AI applications of that. And then I want to point out that in 2019, Ben Shapiro, our Benjamin Shapiro, clarify proposed this move in education for machine learning education as a new focus, saying, we should start teaching about machine learning. So all this to say is that while everything feels super new, people have been talking about this in some form, and there's a coalescence that's happening, but we can absolutely acknowledge that right now, at this moment, it is all AI all the time. And as a lead on AI in education at Stanford, I concur with this fully. But in all fronts, the Biden administration was promoting it. The current administration is actively encouraging it with an executive order issued in April of last year. Can you believe it's only since April that time has passed, to promote artificial intelligence education for American youth, which has trickled down to what NSF and federal funding agencies are doing. I know at state level, the Utah State Legislature is in their legislative session. One of their bills is HB 168, Artificial Intelligence in Education. I guess it was for 2025 general session, so this came in last year.
It's still around.
It's still around, yeah. I think it didn't show that it had made its way out before, but perhaps this is the year for it to get through, but effectively to form a study group or a task force to look at AI in education in Utah. This is very consistent with what a lot of states are doing. In California, we had a couple of bills that had come through, one of which was that all new curricular frameworks and instructional materials need to be adopted with a consideration of AI integration or AI literacy integration into there. So this is popping up statewide. I mentioned the executive order. NSF responded with a Dear Colleague letter in August for funding supplements to expand K-12 resources for AI education. So not only are we talking about AI all the time, but we're talking about AI education all the time. But what I'll also contend is that when we talk about AI education, we're having a really hard time knowing what it is that we're talking about. So putting a quote from the executive order, it is the policy of the United States to promote AI literacy and proficiency among Americans by promoting the appropriate integration of AI into education, providing comprehensive AI training for educators, and fostering early exposure to AI concepts and technology to develop an AI-ready workforce in the next generation of American AI innovators. So we have AI literacy, we have AI concepts and technology, we have proficiency and comprehensive AI training. And as somebody who self-identifies as working in the space of AI literacy, and I can comment a bit on what makes that especially tricky, is this is where we are in precision and articulation, is that we have AI naive, meaning people have heard the term AI, they know about it in media and entertainment, and we have the AI experts who have extensive formal training, professional experience in development of AI. They can go even deeper into the history or talk about whatever software packages or libraries are best for it, or weigh in on what's the future of the GPU. But where do we position AI literacy? Which of these points along that spectrum, or is it even on this spectrum? Because sometimes literacy is treated as an alternative pathway rather than part of it. We even talk about a point or a portion or a range in there that one moves around. So I will say, first and foremost, as somebody who is really active in the space, there is no clear definition of AI literacy. Probably the most cited writing on this is from Drury Long and Brian McGarrico, an ACAI paper from 2020, where they effectively did an extensive literature review of ACM publications to look at how competence in AI literacy is described. And so they identified 17 competencies. They span across recognizing when something has AI in it, understanding intelligence, knowing the strengths and weaknesses of AI, knowledge representation, machine learning, data literacy, sensors, and ethics. So those all sort of fit within that. It's kind of a hodgepodge big list. And other people have promoted lists. I mentioned AI for K-12. Gail, did you want that one slide before I can go?
Not with this one.
Okay, this one. AI for K-12. I know Gail for years, so I'm like, yeah, it's a big track.
Just trying to settle, but it didn't work.
No. AI for K-12 I mentioned started in 2019, so they're thinking about this before it was cool, and I really do want to give them props for that, because I think that with people with platforms and microphones, large social media followings, it gets overshadowed. And so they put forward, after extensive work and review, this notion of 5 big ideas for AI that include perception, so that computers perceive the world using sensors, representation and reasoning, which I think is quite cool, to focus on like how representation operates and is a key part of working in AI. Learning from data, natural interaction, so this is kind of an HCI and a productivity sort of standpoint. And then at the core, and touching all the others, is societal impact. Trying to get at, how does AI impact society in positive and negative ways. And, I imagine that many people here are attuned to some of the same literatures. Is that one of the things that we hear a lot and many recognize is that there are reasons to be cautious about AI. Some of the especially noteworthy cases that exist have been predictive policing, so sort of this minority report thing, statistically we expect to find crimes here, so we're going to go and find crimes here, which is baked into, well, which data it was created and why to have crimes recorded in there, and what happens to sort of our justice system, which I think is a very good meta question. Joy Buolamwini at MIT had a Netflix documentary and some publications on how, as a black woman, the face filter would not recognize her face unless she put a literal white mask over her face, then the face filter would work. And so that just goes to show that the machine learning that was involved did not recognize all complexions, and this is also a known issue amongst other technologies, like even for hand dryers and being able to detect certain hands being underneath the hand dryer. And then Sophia Noble wrote Algorithms of Oppression, which documented how search engines were putting forward as the top search results, I think, racially offensive stereotypes and content. And this was in part a function of the lack of awareness from these teams, but also with what kinds of content get put as key in digital media. So we're seeing a lot of things that are important for AI literacy, potentially, or at least are talked about or proposed. And since 2022, 1,000 AI literacy frameworks have bloomed. So if you've heard just let 1,000 flowers bloom, well, somebody said that to the AI literacy folks, and they're like, let me get my fertilizer. So this is just a snippet. And you can see that whoever does like Microsoft chart art is really happy. You can see that there's competency and literacy and cool arrows and things. And I definitely appreciate this. You work on any framework documents, it takes a ton of work. And these are really carefully thought out documents. They can be like 100 pages long. But there's a lot. And if you run a search on the internet, woo, you're just going to be surprised, and there's new ones coming out every day. I can tell you that the final version of the OECD one is coming out in just a few months. And I'm sure there are others coming down the pipeline. So that's effectively drinking from a fire hose. And I do find, as I engage with educators a lot, educators, and there's some apocryphal note about how there's more decisions made from an educator in a given day in that profession than air traffic control. Like, it is the most sort of work that you do. And so like, here, have 1,000 AI frameworks, each of which is 100 pages, know them and teach them. And even for me as somebody who's working in this space, it's like, I just am trying to make sense, heads or tails. So I convinced Dory Long, who did that Long and Nagarko, to work with me on a book chapter where we spent some time thinking through what was happening to AI literacy. And here's the footing that I would say is that ultimately in these documents, they're representing three perspectives and emphasizing sets of values or priorities associated with those perspectives. One is of the users of AI in the world, where AI will be a tool and resource for all sorts of activities. But that's sort of drawing this idea that AI literacy doesn't mean you have to know how it works, but you know how to work it. There were and are a lot of folks who are computing enthusiasts, and they like the underpinnings of this. You feel like everybody should know the underpinnings of this. And so the perspective that they tend to promote is the one that lays the foundations for possible futurist technical developers. So they want you to know, what's a classifier? What does clustering mean? Now with that, it doesn't mean that, hey, now we're going to hand you a coding environment and voila, you're going to pull it out. That's my code. But you would know sort of those terminologies and have the proper footing in order to go in and talk about those or start to think about those as technical possibilities and further proficiencies you could develop. And then there's also the perspective of AI critics who foresee possible risks and harms, trying to think about the ethics and the concerns both to self and to society that comes with that. And so what we proposed in this is what we call the UDC meta framework, where if we think of this as a space with 3 corners on it, then of the perspectives being emphasized, user or developer or critic, then what we can say is that a framework has different degrees of relative emphasis, such that you might have one that balances user and developer and critic perspectives exactly equally. You might have one that doesn't touch critic topics at all, but is really focused on user developer. That's where there's a beta that happens to sit in there, or one that might lean a little bit more developer than user. And the reason why we talk about this is because with so many documents coming out, it's like, is this one saying the same thing as this one? Is this one really promoting these things that are different from that one? And so I'm going to share a very crude computational exploration I did briefly last year. This is effectively a keyword matching on things that would be associated with a user, developer, or critic perspective. That was terminology that was appearing in framework documents. And I ran a very simple computational analysis on this across 5 framework documents. One was AI for Capable of Big Ideas, Education Council, Honest, EDUCAUSE, and UNESCO's Competencies Framework. This wasn't lemmatized or anything of that sort, so we did include different word variations as much as possible in there. And then looking at this UDC perspective, here's a few things that I'll point out is the relative emphases, at least across these 5, is not as critic-oriented as much as user-developer. Big Ideas is a bit more developer-oriented. And if you do look at sort of the content and examples, like you're talking about, let's learn about different search algorithms, breadth first and depth first search algorithms, which sort of tracks with this, let's learn about sort of the underlying AI mechanics in there. And so that just gives a sense as to like where we are to see where there are differences in emphases and priorities. And so that just for me has been helpful when I talk with teachers who feel like, I need them students to learn this and this and this, and I have questions about this. Like, okay, well, are you trying to think about it from what a user needs to know, or someone who might go on to be an AI developer, or a critic, and then how much do you want to prioritize that as you sort of negotiate priorities within your department, or at your school, or in your own curricular emphases. So one of the big unexpected surprises is we do a lot of professional development and professional learning research in my group that's been very positively received, just because it is a simplification from a lot of things. And what I do recommend is use this to help you figure out how to get your footing with a framework, and then go read these high quality frameworks to understand, but it helps you to narrow the field. So, as I said before, AI literacy is still fully specified. Like, there's just no official definition that is agreed upon. You can go back to that 2-headed arrow, which is everything pointing in every which direction. And it is definitely hard with these appealing terms. There's lots of terms that have a great linguistic and social appeal, but when you try to pin them down, it gets really, really hard to do. But at the same time, even though we don't have that precision, there are not accepted standards for what AI literacy looks like. There are not quality assessments that are not self-report on what AI literacy looks like or how to measure it. But we have an imperative to develop AI literacy, whatever it is, now. And this is a really interesting moment. Like, once a generation, you get these like harsh, we need to put all boots on the floor and move quickly moments in the R&D enterprise. And so trying to renegotiate the socio-technical world with AI is part of that. So I'm going to share 2 cases of AI literacy learning design that have come out of my team. And I'll point out here that on the left, you're going to see an eyedropper generated with AI of learning sciences, which is my home doctoral field. And understand great learning sciences program in the development here at the U. But I'm sure when you see this, or if I were in the audience seeing this, I'd say, why is it an eyedropper? I want a big old picture of learning sciences poured all over this thing. And I have that as my wishful thinking. because part of the message here, and I think this just sort of speaks to this pragmatist disposition, is I think there's a lot of reasons to consider we may need to work with the droplets and push from there. So let me talk a little bit about some of those. Let me talk about curriculum materials. So if you're in science education at the K-12 level, there's been tremendous progress, research-informed progress on new frameworks, new conceptualizations of science education. I think these are very good things, very good direction, and there's great work happening on that. And then one of the main research-informed initiatives is the development of a curriculum, a whole curriculum program, because it's spanning from elementary to high school, generously funded in part by Carnegie and others, is open science education. And it's exciting for me because I have seen the scholarship and the years of work, and I was involved in data collection and meetings for work that preceded this, to see oh, it's actually making its way out there, and the work is hard. But I'd say definitely get familiar with what Open Sci is doing, and there's these really interesting innovations. And these curricula, as you notice here, they're question centered. This one out of iHub. iHub is based out of CU Boulder. Why don't antibiotics work like they used to? So they think a lot about how to build storylines and driving questions and question structures that will get you in contact with core scientific practices and content, and cross-cutting ideas,
Cross-cutting concepts.
Concepts, thank you, and disciplinary core ideas. But I want to point to this set of bar charts on the right from a recent RAND report that just came out last year. And this is a study of teachers' use of instructional materials from a fairly large pool. And let's take a little bit of a look in here, and we'll just focus on science right now. So science is the one on the far right. So if we just look across science, regardless of grade level, or if we look at grade level, high school, so let's go science and let's go high school. People who are working by the book, which is I stick with the curriculum that's provided, it's less than a fifth here, less than a tenth here. Folks who will work with what they're given but modify in there, which I commend. A lot of education research is focusing on adaptation more in teacher design capacity, pedagogical design capacity of curriculum. That's another 10% or 8% there. And then what I want to draw attention to is the purple and the blue areas, which is the vast majority. And these are called DIYs and cobblers. These are folks who put together their own curriculum. They write it themselves, or they kind of curate from other stuff. Here's a cool lesson from a textbook I used in my last district, or something that the district made that I can tweak around, or whatnot. So, despite a very lucrative industry for textbooks and curriculum, that this is more of a portrait of what actually happens. And I think I see a few knowing smiles from people who are coming from the classroom, yes, obviously this is what we do. But I think that's really important, is obviously that's what we do. And with all acknowledgement to the importance and quality of work like Open Sci, where it's an 8-week unit that ends up taking 15 weeks in the classroom, sort of a thing, to be very demanding, that there's this friction with what tends to happen in practice and how do we speak to them. Now what I'll also say is the internet is a great and terrible place for secrets. So one thing I found really interesting, and I was talking to my colleague Stina Christ in Science Ed, is there's an NGSS social media community, and I was struck recently by some conversations. So I'm going to share the emojis mask the identities on this, but this is in the NGSS. I do not know a single secondary science teacher who's using Open Sci that thinks it is a good curriculum at the high school level. Teachers who have experience teaching AP science classes point to the many flaws that result in students who are well prepared for inquiry but lack foundational content knowledge. I don't recommend Open Sci. It needs a lot of support and isn't really accessible to lower level kids. Not OSE, Open Science said. Anything else would be better. And there's a lot of likes that come with this from the NGSS support group.
Yeah.
And this is the most aligned. I have on the right a website that, if you don't know what TPT stands for, it's Teachers Pay Teachers. And again, I think there's a cadre of classroom educators who are like, oh yes, I make a few bucks every month from that, and I go and use that. And what's Teachers Pay Teachers is basically an internet marketplace for teachers to share lessons or materials at very modest cost, $1 for a lesson or $1 for a worksheet that you can use. Now the problem, I'd say with Teachers Pay Teachers, is you have so much under the sun that the quality control is very poor. And in the analysis I've seen that tried to see alignment to standards or best practices, very poor. But teachers regularly use it and have a lot of incentive to use it. So if you think about all those DIY teachers and all those DIY or those cobblers, this is a big part of the teaching ecosystem. And then we have a vision that and work that's looking at how we expand the universe of Open SciEd and other well-designed curricula, but we also have a big question to address. One other thing I would point out to is in thinking about our conversations with how do we deal with AI, if we're going to try to teach AI, is the importance of context in which AI is used. AI is talked about as it is just this new own topic by itself, but AI is pretty meaningless if you don't have anything to AIify or use AI on. So I'm going to put in this quote that's gone viral. Since I'm at Stanford, I see this quote all the time. I don't know if it's really gone as far, but our news media will. There's a famed radiologist, Curtis Langlotz, who has a quote that's circulated: AI won't replace radiologists, but radiologists who use AI will replace those who don't. So if we think about that, again, with the help of AI or a radiologist looking at scans, and that's hard, trying to see what's going on in there, and I'm always appreciative if they find something important that we should flag. But are they saying that, hey, all radiologists will be coders and working on AI code? I don't think so. I think when a radiologist uses AI, they're using not the code side of it, but rather the tool side of it. And so we want to think about, if we're going to teach people AI, that's probably going to be embedded within an actual context of use. So where this is all going to start heading towards is thinking about what kind of stuff would we want to teach about AI, think about it in context, and think about the fact that we're trying to build this very long curriculum only gets to a very small segment and perhaps very strong emotions about that. But we can't think about, all right, this UDC perspective, we want to think about use, we want to introduce a little bit about mechanisms, we want to introduce some things about cautions, the exact degrees of which are TBD, and I think there's an important empirical question. But what I've approached in my work and how I feel like I can make the most headway is to think, all right, there is a time commitment that is required, and if you want something that we make out of a university to have actual use, it has to be a low time commitment. It has to fit in a class period. Oftentimes the class period expands to 2, but regardless, we have to think smaller than the 8-week unit. It needs to be modular for the teachers who adapt and curate. As a literacy endeavor, we want it to present complexity in simple and relatable ways. We're not going to, argue the merits of K-means clustering versus all other clustering techniques in there, because that's probably a little bit too much and gets further to the right on that AI literacy double arrow I said. And then we want to make sure that, for us to feel good at night, it adheres to accuracy and values, so ethical and intellectual values. Are we representing AI correctly in terms of how we want people to think about it? Are we, making sure to elevate ethical concerns that are going to hit the right spot? So I'm going to present 2 cases of the work that we've done in this space over the next 15 minutes. The first one is AI quests. So this is a project that is done with Google Research. One of the things I appreciate about Google Research is they are very active in academic research. It just happens to be the way like Microsoft Research has MSR that they are an organization that maintains these active R&D wings, and they have stuff that'll participate in research spaces. And Google Research has done projects, and they have autonomy to a degree to pursue things that are not all about search. For instance, they're not all about advertising, but they do research related to business and products and science and society. So here's a few examples out of the Google Research Group: using AI to forecast flooding and save lives, increase access to diabetic ice cream, using AI to map the human brain, using AI to predict and detect wildfires. So I'm going to talk about the first two because those are the basis of AI Quest, which is a middle school targeted resource, although I've had people of many age groups have a good time playing with AI Quest. So this is based on actual AI research projects at Google Research. Want to acknowledge my team here from Stanford, from Google Research, and from Phantom, which is a media production company. And I think anything that people ooh and ah, whether it's the cuteness of the characters or the quality of the visuals and the interaction, is to Phantom's credit. And I can say more at a later time about the really interesting intersection where you have digital media creatives and a tech company and education scholars all sitting in a room together, and what different parties are bringing to that. But AI Quest is an interactive, narrative structured game to enter the AI literacy space and follow AI from problem identification to real world deployment. Because a lot of times AI literacy lessons are, let's simulate as if we are a neural network, but it doesn't situate that in an actual activity and with the ways in which these things truly unfold in a human endeavor. So I'm going to play shortly a video. This is just the, if you go to AI Quest, there's this first intro video. If you've not visited it previously.
AI expert and your mentor throughout this learning experience. We have been waiting for someone like you. You're about to begin a journey through our world. As you travel, you'll meet different inhabitants and learn about the challenges in their communities. Your mission is to help them by applying powerful AI responsibly to their problems. Each quest will teach you about a real-life AI research project that's making an impact back on Earth. The AI technology you'll experience is amazing, but it's not magic. Success depends on the decisions you make. You'll need to collect good data, train your AI to make smart choices, and test it to make sure it's reliable. The universe is counting on you. Are you ready?
So as you can probably glean, this takes place on an alien world. And let me show you a little bit of a walkthrough briefly of what happens in the flood forecasting quest. Is that you meet this character Luna, who is a pedagogical agent in this space, to situate the problem and show why it's a problem. The floods basically flood out the markets, which is the livelihood of the people in the community. They don't have enough warning. It's very damaging. They lose a lot of product and opportunity there. So from that, or AI could be something interesting. You go on to AI data collection adventure in there, and I'll talk a little bit more about the data collection portion of this. Then you go on to do data cleaning, looking at anomalous values in the data and marking it as something to flag or remove. Then selecting the data from the larger body of data that you collected to train an AI model, testing that model for making predictions, and then when it is at a satisfactory level of accuracy, which we do not allow to ever be 100%. Because that is one of those messages going back to these values of accuracy, intellectual values, to show we will never get 100% ever with these, but we can think about these with high accuracy and higher accuracy to use that knowledge to help the market solve the basement in preparation for a newly discovered anticipated flood. Let me talk a little bit about some of the learning sciences droplets that we bring into this. And I'm going to intermix a little bit of the diabetic retinopathy quest and the flood forecasting. So this is from the diabetic retinopathy. One of the things that appears in the learning sciences and educational technology literature at large is pedagogical agents. These are specialized kinds of digital characters in online experiences that can provide, in our design specifically, to provide scaffolding, tutoring, coaching, or other forms of guidance. And so this was something that we really stressed and formulated in our interactions in this design, where we have, for example, the sole optometrist in the region as the content or subject matter expert. We have Arlo here, who is the assistant who is going to learn about AI from us. And so they are a teachable agent. We have to teach them the stuff that we know as another measure to further articulate the work. And this is one of the teachable agent interactions with Arlo says, so what I need to do when I clean the data is these things, and the student helping to steer that process. Another learning sciences droplets is there is something, especially in the psych region, known as the self-explanation effect, and this is something that a lot of researchers in reading comprehension and in math and many other areas try to inculcate in certain practices, but effectively continuing to develop a self-constructed explanation live dynamically of the situation and articulating that. And Mickey Chi and colleagues is core to that. And related to that is just the practice of reflection on experience and activity. So we foster these dialogue interactions to select what would be the most sensible with the right or wrong options in here. So first, in understanding what is this quest, I'm glad you're here. Before you start, let's get clear on the mission. What's the problem your AI model needs to solve? To invent a cure for eye disease, to help predict eye problems so more patients get care, to give medical advice that patients don't need a doctor. So we're trying to pick on things that actually are what people suspect might be part of AI, but the content of which was just talked about into a work of articulation. We have at the end students produce a report for whatever obligatory reason, whether to send back to mission command or to give back to the local community there and help sequence what were the steps that we had taken in here and in what order to help understand why and where we're doing testing versus deployment. Other droplets is we are putting in a lot of failure and feedback mechanisms. So one, but not the sole, author Manu Kapoor is written about productive failure. But we put in what we call these failure loops, where we have the specific spots that you can get it wrong and go back. So in the flood forecasting, one of the things is if you don't select the data for your model training that gets you above, I think, a 70% accuracy threshold, you got to go back. Like, we can't move forward with that and go and figure out what is going to be more useful data, but then there's the immediate scaffold here to show which of the data you did select are highly relevant. And so in those data, you have things like humidity, soil moisture, but we also include things like sorbet sales from local sorbet stand. Why? Because data can take many forms, and we even talk about how, the sale of that might influence it. Now, for this particular investigation, it's not super relevant, but representing data and all the different things data can be and can be harnessed is an important value that we put forward in this. So here we have a 50% accuracy, and then you have to go back and reselect the data until you get higher accuracy, and then in the text it says, great, you have this higher accuracy. Keep in mind, though, that we can never get to 100%, but this is good. This is good for progressing further. And then finally, we also think a lot about accessible, appropriate representations for AI models and the training of AI, which is, a college level course to try to think about how do we use linear algebra and eigenvectors and what's a neural network in the first place. So I'm going to play very quickly a video that we spent a lot of time on the design of the visualization of what happens with training in AI. So first off, and I think that this is all with dialogue. So we were check for privacy, ready to learn with the AI model. So we start training by giving the model input data to learn from, and got it from the subject matter experts. Now, AI models don't see scans the way we do. Instead, AI works with things like numbers, so we convert our inputs and scans to a form AI can use. Again, aligning with our values and sort of accuracy in terms of how you think that representation is involved in here. So these all dissolve into numbers and go into this neural net type thing where you don't need to pay attention to the values, but as the training happens, the numerical values change over time until it starts to get the predicted outputs in there. And so try to break up that input, model, and output sequence. And this becomes a recurring thing throughout the quests. And then at the very end, after the students complete the quest, they get a badge, digital badge, because it's an online game, to commend them for it, to say, you know, this is actually a lot like an actual project that happened. Would you like to see? And here's the video. And we did this with an eye towards expansive framing, being a conceptualization of transfer to take disparate seeming experiences, but recognize that these are all instances of the same. So here's the video for the flood forecasting.
Our team uses AI to predict where floods occur around the world so that we can give people warnings and help them stay safe. The quest you just took was inspired by our journey.
What I love most about our work is that we're using science and technology to make a real difference in the lives of millions of people, especially in places where floods can be devastating.
Floods are serious. They can destroy homes and cut off communities. But with the right data and the right tools, we can help reduce the impact and minimize damage. As a result, communities can recover faster after a flood.
So here's how it works. This should sound familiar because it's very similar to what you've just done during your quest. First, we gather tons of public data. Things like rainfall, water levels, weather forecasts, and satellite images. We review the quality of the data and make it necessary.
Then we use AI to create detailed simulations of how water moves through the environment. Think of it like a virtual model of the real world.
We train the AI model to predict when and where water will run, how fast, and who will be affected. This kind of prediction is called flood modeling, because even small changes in rainfall can completely change how flooding behaves.
Once our models are trained, we test them for accuracy. We then use our models to send early warnings, sometimes days in advance. These alerts show up in Google Search, Google Maps, and in some cases as notifications to your cell phone.
We also work with governments and rescue, so they can act fast, help people on the ground, and get them out of their time.
Our system covers flood-prone areas in thousands of locations around the world.
And we are still working hard to expand to even more locations, because we want flood forecasting to be relevant to everyone who needs it.
It's important to remember that AI is a team effort. It involves many people from different backgrounds and different points of view. We have scientists like myself who are experts in floods, and we work hand in hand with engineers like Tal who are experts in AI.
We hope that this video helped you understand how everything you have done works in as a labor.
Back to you, Professor Sky.
Alright, so some of the things I talked about, the data cleaning, you can see images that bear a resemblance to how the model looks, and so trying to build in that alignment, but also recognize some of that complexity. The values also that, you know, of how this requires multiple expertise areas. So what's next with AI Quest? There is a new quest coming. It'll be released later this year, mapping neural connections in the brain from 2D slices, which is a very, very hard problem. I don't know if any neuroscientists in here. I don't see the nods of agreement, but you can imagine it. It's a lot of work. Internationalization and unplugged versions for broader accessibility, recognizing that not all computers are one-to-one. Classrooms, even post-COVID, or especially post-COVID. And then I have some initial Think Aloud research with my PhD student, Judy He, that she's undergoing following, hopefully this week, IRB clearance, to study how the students are, in a sense, making across the adventure. And then Raspberry Pi just announced that they're integrating this into their Experience AI curriculum, which is used heavily in England and a few other countries. Now, the second example, and I'll go quickly because I see it's 1:45, is my project CRAFT, which CRAFT is an acronym because if you've been around the academy long enough, you know we love to make acronyms, is classroom-ready resources about AI for teaching. So this is done with what in learning sciences we're very into right now, a paradigm called educational co-design. I know we're really into it because I'm editing a journal special issue. We solicited proposals for it, usually for a special issue where you're going to publish like 8 papers max, like 20 submissions. We got 125 plus. That was a fun weekend. So yeah, the interest is really high in co-design as a paradigm, but also, you know, one of the things I puzzled through is how can we do the time-intensive work of co-design which is taking a long time, and get meaningful insight out of it. So one of the things I am a proponent for is using co-design records as a source of research. Look at those interactions and to analyze that. And so I'll talk briefly about one of the analysis we've done. There's things that we integrate also from learning sciences in this, driving question structure, which you also saw as part of Open SciEd. We intentionally position AI within the disciplines because we don't think there's pretty much any school, Alpha School included, that has time to just teach AI as its own subject, but rather you can teach about how AI is relevant to or connected to bio, how AI is connected to math, how AI is connected to art. So we encourage when we work with teachers in co-design, but I think there's also this pragmatic attention to reality. LS, or learning sciences, shaped learning activity structures, which are hard and complex and I think worth doing, but also, it's probably, there's still work to think about in terms of how to fully foster their implementation writ large in businesses. So this is the resource repository. I think if you go to craft.stanford.edu, it will take you to it. And then we have a large selection of tiles around different subjects, co-developed with teachers and associated lessons and lesson plans and lesson materials. And here's like one thing that we even stay attuned to. Teachers oftentimes appreciate having a Google Doc or Google Slides rather than a PDF because they want to edit or copy from that. And so just thinking about like what is the format that is really going to be useful and to embrace adaptation as the norm. I'm going to show quickly a high school statistics set of resources that Victoria Delaney, who's now a professor of math education at San Diego State, developed and incorporated into Craft. And this was an integration with and focusing on high school statistics content and using the measures of variability and error that are introduced in there. But to ask the question using those tools as approximations, how do computers see and understand visual information? How does my phone unlock when it sees my face? So included in that, is this little widget that she made, which I think you can see on a coffee cup? All right, in there. So it's a very pixelated depiction of what humans see, but what a computer sees are numbers here, which we can take a look at the human sees. And then from these numbers, if we take a picture of it, we can use those numbers using some of the tools of statistics, which the students will do to create thresholds for what is or is not okay from the variability standpoint in there. So this has become an add-on unit for high school statistics classes, positioned, for example, after AP testing, but they still have some class time and want to talk about AI in there. But this is very much designed with what is the high school going to cover and how can we approximate enough of the things while also recognizing and opening up the conversations about facial recognition technology and why might we be concerned and why it might be mistakes. I mentioned briefly, we analyzed the co-design record, so I have a wonderful postdoc, Joba Adisa, who has expertise in epistemic network analysis, which is a particular computational technique that effectively looks at co-occurrence of certain coded elements across a longitudinal record, idea transcript. Anyway, so we looked at teachers' co-design transcripts across a year-long cycle of participation in craft co-design. And one of the interesting things was how AI literacy was talked about and expressed and seemingly prioritized in the ways that they created curriculum. So in this example, and what happens from epistemic network analysis is you get these diagrams where I think it's fairly intuitive. The bigger the line, the thicker the line, the bigger the dot, the more. And if the line is there, it's the co-occurrence or the connection of that. So Simone, a veteran social studies teacher, is really focusing AI literacy, thinking about using AI as a tool, using it to support learning, and responsible AI use. Alternately, Margot, an early career English teacher, was more emphasizing understanding AI mechanisms, career readiness, and assessing AI output. So I think even with this space, and just to reiterate, AI literacy can be represented in many different approaches and slices of things. We have two teachers who went through the same experience, representing different subjects and how they're operationalizing, prioritizing, and talking about AI and what they want to stress and emphasize in their respective positions. So what's next? With CRAFT, we do have a new cohort of teachers, and this year we're doing only science teachers, and they're meeting Saturday. To develop CRAFT resources this year, we will continue to incorporate other resources that exist, including things like AI Quest, which does have presence there, and then we just added Yasmin Cafe's new algorithmic auditing curriculum into there too. Some forthcoming papers, credit to Joe Badisa for actually doing the hard work of writing those, and then exploring further growth, i.e. I'm working on some funding proposals, because that's what I do in all my spare time. So summary and eye to the future. We're at a time right now that there's pressure to examine what it is we teach. In a future, we expect to have AI all over the place. So AI is the topic. Nancy will tell about a forthcoming National Academies report that's going to speak to that. Some sneak previews of things. There is going to be a push to integration into existing subjects rather than trying to replace out. And then elevating data and models and the risks associated with those. We have many areas where we lack precision, and I will say that there's times when I just fret and wring my hands where it's like I don't feel like I can pin down, stick my knife in the table for like, yeah, literacy is this and this is the benchmark for it. But we also don't have the time to get precise in order to make some progress and get things out there. But what I would urge is as more people participate in this space, and 50,000 AI frameworks that come to bloom are any education, there will be people who come into the space. Bring educational expertise to interface with the STEM expertise. It can lead to really interesting products and discoveries and get to a much better path than many alternatives, such as some enthusiastic ed tech or tech background person comes up with, this is the curriculum, this is the solution, which is quite common. But also at the same time, while we have ideals and things that we know from research would be really good, is I would say don't let perfect become the end of getting good. I think it's time we still make headway and progress. So thank you. May we all work towards an AI education and lead us to a future that's more like Data and Baymax, and a little less like Megan, especially Megan 2.0, and Terminator, which is now on like 7.0.
Yeah, thank you, Victor. Shell and I have wondered, because we're big Star Trek Next Generation fans, like someone wants to do a study of how many learning sciences people got interested in because of Star Trek.
Not happening now with Starfleet Academy. That's a different conversation.
We have a few minutes for questions, so please, if you have one, raise your hand. Yep, let's get started.
You mentioned that you will soon be working with cohort science instructors. When you were doing your presentation, I understand how CRAFT was trying to lend itself into AI education and literacy development, but also couldn't help but gleefully respond to the phenomenological or maybe inquiry-based learning style of the AI Quest, AI Quest is model. My question is with respect to this cohort that you are working with. Is your intent to see how AI literacy can be co-engineered into completing with maybe NGSS expectations using inquiry-based learning, or is it more on the lines of distilling AI literacy?
With the integration projects, I would say the former, which is very much like NGSS, and there were funding initiatives around like how do we integrate computer science into this computational thinking.
Right.
And I think it's an interesting intellectual challenge in how we think about the nature of integration, but also not so much as integration, but practice change, where programs, simulations, and computational tools are part of scientific practice, and so that's sort of a challenge for us to how to think about the pedagogically appropriate access points to engage with that, because that is the world that we work in. There are some projects broadly where we focus more on just AI literacy as a topic, but with things like CRAFT and elsewhere, the question is how can we make real connection points to that discipline from where the teacher sees their main teaching goals or priorities are.
And would that also be the use of pedagogical agents moving forward?
Pedagogical agents was for the digital game experience, and so I think that's, I love the learning sciences. There's a lot of cool stuff that we've made headway on, and I think good work should continue, and I think pedagogical agents is among those. I don't think that everything requires a pedagogical agent, But, by all means, there's some good work to do with pedagogical agents, teachable agents. Django was telling me about some really cool things that he's working on, which sounds really promising.
Yeah.
Would you have any advice for undergraduate students or even graduate students on like practicing any of this?
Yes. Well, we need to open up the conversation space between students and faculty about AI and what is the appropriate uses of AI for what purposes and why. So I know that what you do in school is a concern, but I also think that in your post-college career, you will have AI available as tools. In some ways, you can't run a Google search without getting AI right now. And so what does that mean? Well, we need to cultivate right now practices of discernment, verification in there, because AI hallucinates and gets things wrong, and that will not go away. And so thinking about how can we productively use this, or we might use it to help generate code, but then how do you check and use that carefully? So I think we open up the space and focus on how do we do this in service of the larger disciplinary endeavor. And that's what I hope for undergraduate education and graduate education to do, is to start to show what does it look like to do physics and astronomy work now that we have AI tools available to help us get through these terabytes, petabytes of data that come in. And how do we test and think about this, and where do we feel confidence and not confidence in that. But I would say, I don't think AI is not good or evil, it's just there. It's a tool. We should know how to use tools, but we should also know how to use tools responsibly. And then in higher education, we need to open up the conversation space, because educators are very afraid that if they say the word AI, that gives license to just do anything, no matter what. And we have important pedagogical aims for certain things, but they're not necessarily fully communicated in that trust and rapport is built.
Thank you. Let's do one more, and then I know we'd love to run.
You talked just very briefly about sort of how ed tech is trying to sort of flood this space a little bit. Do you think that, like educators and researchers who were already sort of in the AI space before it went crazy, do you think you're going to be able to get ahead of ed tech in deciding, what goes into classrooms, what is best practice, and these kinds of things?
That is its own, I think, area of scholarly importance to think about as to how things move and migrate across spaces, and it's more almost a sociological, institutional thing.
Like an STS question.
Yeah, or networks, or organizational studies. Do I think new stuff? I think there's value in what we do from the academy in partnership or in our own work. And as I was saying at lunch, I think the challenge for us right now is to reassert that value, because we've not done a very good job in asserting that over the past couple of decades, and that's contributed a lot to where we are right now. For example, I am in the academy and in education, so clearly I didn't go into this field to make a lot of money. But that's because I want to get good ideas out there, and if people start using them, then that's a win. And so then just to think hey, our job is to pioneer in the ideas, other people can take it to market, or if you want to switch careers and do that. But I think communicating that, so what I communicate to folks and ed tech folks is look, I'm here putting forward the ideas. I'm trying to think about what the research is telling us and where we know stuff or don't know stuff, and to assert those values. But at Stanford, there's unique capabilities given its positioning with Silicon Valley, but I think that it's still a giant collective endeavor that we do one conversation at a time.
I take solace in, I hear the same comments from teachers about your open science comments. I hear the same comments from teachers about it, right? So you're just rightfully cynical about a lot of things, and I know that there's a big push from EdTech to get into public education because we're a huge opportunity for capital. But I think that's why we're important too.
EdTech presents the solutions that no teacher ever asked.
That's exactly right. And on that note, let's give Victor a round of applause.